Welcome back to Maths with Mrs. J. We've been talking about sketching quadratics, and we've talked about the very basic garden variety parabola is y equals x squared. In our previous video, we investigated what changes to our parabola were made by having a positive or a negative out the front, a number out the front, a minus b in with the x all squared, and a plus c. Now, as with pretty much any function, if you have a negative out the front, it's going to turn it upside down. So your normal y equals x squared looks like that. It's concave up. If you have a minus, it's going to be concave down or upside down if you want to think about it that way. What other changes can we make? Well, let's think about this for a minute. If we are multiplying by a, if a is bigger than 1, then our parabola will be thinner, it will be steeper, because it will increase in value at a faster rate than your normal y equals x squared. So it's going to be steeper if a is greater than 1. If a is between 0 and 1, it will be less steep. Now we can think of this as thinner and fatter. And no, I am not fat shaming a parabola. This minus b business, what did that do? Well, that moved it b to the right. So if you have an x plus b squared, obviously it will move it to the left. What does this plus c thing do? Well, as with any function, whether it be a quadratic, trig function, whatever, it's going to move the whole thing up by c. If c is a negative value, then obviously it will shift it down by that. So that's your vertical shift. So let's just look at an example and have a look at how we would adapt our normal function. So say we had y equals negative 2 x minus 3 all squared plus 1. And we wanted to get a bit of a sketch happening with that. It doesn't have to be terribly accurate. We're not reading values off it. We just want to get the basic shape and see what it's going to be doing. So let's have a look at this. What adjustments have been made? Well, it's a negative for starters, so it's going to be concave down. Because it's a negative 2, it's going to be steeper than our normal y equals x squared. As far as our shift is concerned, we've shifted 3 to the right and 1 up. Now, that can actually tell us where our turning point is. Let's actually do a little sketch of some axes and I'll show you how this works. Okay, so we've got our axes here, x and y. Normally, your turning point of your y equals x squared would be here. If it was y equals x squared, it would be here. Y equals negative x squared. Turning point's in the same spot, but it's upside down. We have moved, instead of the origin, our turning point is now 3 to the right, 1, 2, 3, and up by 1. So our turning point is going to be there, okay, because we've shifted it 3 to the right and up by 1. We know it's going to be upside down. If we wanted to actually be able to demonstrate how skinny, shall we say, or how steep the parabola is, what do you think we could do? Well, it would make sense to use x and y intercepts, because that can then give us that little bit of added information that will help us place it in the correct amount of steepness. Now, if you put x equals to 0, that will give you your y-intercept. So y will be negative 2 times 0 minus 3 squared plus 1, which is negative 2 times 9 which is negative 18 plus 1, which is negative 17. So I didn't really get my scale quite right here. Let's just fix this up a smidge. I'm going to have to go all the way down here. And let's say that that's to scale. All right, so the y-intercept is there. What are your x-intercepts? Well, your x-intercepts occur when y is 0. Now, we've already got this in the format that's quite simple to solve. We've already got it with the square completed. So what we're saying is that 2 lots of x minus 3 squared is 1. So x minus 3 squared is a half. So x minus 3 is plus or minus 1 on root 2, root 2 on 2. So x is 3 plus or minus 1 on root 2. Now, what are those values approximately? Obviously, one of them is going to be a bit less than 3 and one of them is going to be a bit more than 3. I worked those out to be approximately 3.71 for the bigger one and 2.29 for the smaller one. So when we plot these, so they're going to be sort of, you know, here and here-ish. So you're going to get a fairly skinny parabola happening. It's a little bit tricky to do, but we're going to get this kind of situation. So that will be your y equals negative 2x minus 3 squared plus your 1, roughly.